So our current job is now converge, and let's go into the input for the job. A lot of the models that we've run so far have been rather small. This is not that small. This is a larger model. There are many different types of nonlinear supports in this model, and there's also a wind load in the model. And wind loads will give us some issues when we talk about nonlinears. One recommendation I will give you is that if you have nonlinear conditions in your model, don't run wind load by itself. Wind load will basically work in a horizontal direction, so it will not develop a lot of normal load on your Y supports, and your Y supports will slide too much. So I would suggest that when you have occasional loads, and we'll talk more of this later, for example like a wind load, that you run operating plus wind, not just wind by itself, in order to see how these nonlinears will react. If I look at my restraint table, here are the restraints in this model. Here's a plus Y support at node 92. There's my coefficient of friction. Plus Y, coefficient of friction. Here's a plus Z, not a negative Z. So that's no friction, but it's just a directional support, nonlinear support. Here's an X restraint with a gap. Oh, here's the minus Z to go with that plus Z. We have unequal gaps. Got 3 millimeters on one side and no gap on the other side. So we got friction, gaps, nonlinears, and let's see what happens when you run this through static analysis. So I will click the running man, run the analysis. Now on the monitor system I'm using here today, I have a 2-monitor system, and the iteration screen is going to come up on the second monitor. I'm going to drag it over. You're going to see it when it happens, but there's going to be a little delay on my side. So I start the analysis. I'm using the default load cases, building the stiffness matrix, and here we are. My machine is now not going to give us an answer. It is not converging. This is the Gaussian elimination of back substitution that happens through that big stiffness equation, F equals Kx. I am currently on iteration number 1000, 1400, 1500. It can't find a solution, but it keeps on trying. It's caught in a loop. Now, what you do in this situation is you stop it, but we can get some information out of this. First, I'm going to click on F2, single step through restraints. So that did not stop the process. I get nervous when I see too much of this. So let's look at this up here. We have 6 load cases to analyze, and we're having trouble with the first load case. That's the operating load case. I've already tried to do this solution 2,600 times over the last 34 seconds and still can't find a solution. Now if I hit continue, it'll just continue to the next step. There's the next step. See, the count went 2669, 2670, so I can see what the current status is for each iteration. If I click on this button again, it goes back to its loop. Okay, turn that off. Now, the nice thing here is that the program tells us that of the 30 nonlinear restraints you have in the model, 7 are not converged for this iteration. Now if I say continue down here, let's see if this number changes. Still 7, 7. Yeah, we have 7 restraints here that are always giving us a problem. Now if I look at these restraints, first we see a node number and a direction. So this is a Y restraint, 262 XYZ. Here 264 is in the Y direction. Do we got any that are not in the Y direction? Here's 312 in the X direction, XYZ, Y. So it's mainly Y supports. Now, the text that appears with each one, generally it's talking about friction or opening and closing gaps. So at 262 on the Y support, let's call it a plus Y support with friction. Before, on the previous iteration, it was closed. In other words, no gap. It was pushing down on the support, on the structure, and what happens now is that either the normal load has changed more than 15% or the angle of response or the sliding direction has changed more than 15 degrees, so it has to iterate again. So this is a sliding error. When I see sliding error, I think friction. This is friction. Now at 282, that's a plus Y support. Before it was closed. In other words, the pipe was trying to push down and the support was active. But now, based on the other responses in this iteration, it actually wants to lift up. So here is a purely active-inactive situation. No friction is involved here. And usually I focus on these types of restraints to clean them up. So that's one in the Y direction. 302 is a sliding error. 312, open and closed again. 312, this is the X direction, open and closed. And then now friction. So I'm just going to pick one of them that is easy to modify. And I'm going to go back to this one, 312. 312 in the X direction. That's open and closed. And probably the next direction is open again. I'll just 312, closed negative, new state open. Open and closed. Close and open. So the program, as it mixes all these different types of corrections, can't get this to settle down to a single solution. So what I'm going to do is I'm going to remove the X issue here, the nonlinearity there. So I'm going to say cancel, and I'm going to abort the run. So I'm back to my main menu. I'm going to go back to my input. Again, that was 312 in the X direction. So I'll find 312. Here it is right here. That's this restraint right here on this piece of pipe. That's a current element going 310 to 312, so that's 312. And if I look at my input, I get a gap of 3.175. I'm going to get rid of that gap. That's the easiest way to clean up a nonlinearity. But I'm going to write down that number. It's wise to track back what your changes are. So I removed 3.175 as my gap and the X restraint at 312. I'm going to run this model again now. I'll run batch. And once again, I'll bring my screen over here. And this one too is having an issue. I used to have 30 restraints. Now I have only 29 nonlinear conditions. Once again, I'll single step through restraints. And now I have 5 that don't converge. 2, 3, 5, 2, 3. So you see we're caught in this loop now. And let's take a look at this one, where there's only 2. That's probably a good place to start. These both have friction in them. I'm going to not fool with friction yet. Open, close. Here, this is even nicer. At 410, a Z restraint, open and closed. So let's pause the video here and we'll carry on after this. We'll get rid of one of these easy nonlinears.